Hello viewer, welcome to another discussion on oscillatory or vibratory motion. Now I want to look at a case of a simple pendulum. I want to look at a case of a simple pendulum. This one will lead us to period and frequency of oscillation. And for the time period, it is simply the time required to complete one oscillation. It is simply the time required to complete one oscillation. That one is for the time period. Okay, later we are going to look at the one of the frequency. Okay, we want to just look at the time of a period of oscillation first. We want to determine and derive the formula for it, and we also use it in our subsequent teaching. We apply that same formula to solve problem. Okay, now let's look at a case of a simple pendulum. We want to look at it. I want to displace this simple pendulum so that this simple pendulum will move, will oscillate, or it will move and swing and in a different direction. Okay, it's going to move repeatedly or periodically at different position. Okay, now I want to look at it now that for a small displacement, for any small displacement, this pendulum, this pendulum ball, it form a small angle. It will form a small angle theta. And don't forget, for any small amplitude, the time period of oscillation remains the same. Please take note of that. For any small amplitude, the time period of oscillation remains the same. The same also applies to the length of the string. The length of the string also remains the same. It is constant. It doesn't change. Okay, now, from what we have, the information we are going to determine the time period of oscillation. Let us see from a simple pendulum. Want to displace a simple pendulum. Want to displace it. As you displace this pendulum, okay, as you displace this pendulum, what happened? What happened to it? As you display this pendulum to this position, it will form a small angle. For this displacement, it will form a small angle. Okay, and we have a weight force as well. We have a weight force at this position. Okay, this one is W, and there is a force here, and that force is known as mg. This force here is known as mg sine theta, mg sine theta. What are these one? We have another one here, and this one here is mg cos theta, mg cos theta. This one is mg cos theta, and if here is theta, here will also be theta. Please take note. Here will also be theta. Okay, now looking at this one, there's a displacement here. Please take note. There's a displacement here, and the displacement here we follow this direction. We follow this direction. Okay, it will follow this direction. Please take note. It will follow that direction. And this displacement, we are going to call it x. We are going to call it x. That displacement will be x. Okay, now you can see the direction. Do you know when you release that pendulum ball, what happened to that pendulum ball? It will come back. It will come back to the original position. I can decide to call this T. The tension here will be TO. Tension here will be TO because this one is the original position of the pendulum ball. Now it was here, and then we decide to call this one T. Now this is a system. This one is already a system. We need to now resolve the system. We need to resolve the system into components. Now to resolve this system into components, we have to look at this stage. We are looking at it at this stage. Meaning what will be the component here? The only component here is y component, and this one will be n. There is sigma fy, which is equal t. The t is positive, and the w is negative. Therefore, here is 0 become equal minus to, okay, minus mg. Okay, now taking it over, we have to equal mg. It means that at this position, the tension there is mg at this position. The related force there, which is the tension force, is mg, which is the weight force. It means that it is the weight force that will support this very tension here. And please don't forget, I said earlier that the length of the string is constant. It's the same as the length here, meaning it doesn't change. If here is L, there will also be L. The length remains the same. It is constant. Okay? Now for this, now I have resolved this position. Let me also resolve this position here. Let me also resolve this position. Please don't forget I said here is mg sine theta. You don't forget that. Now, to resolve this position here, we have two components here. And the first one is fy component, which is the sigma fy. This one will be, what is it there? We have t, which is positive, and the other one that is negative there. It is this one that affects this. Please take note, this one is mg, this one is mg. It has already affected this one, which is mg sin theta. It also affects this one, which is mg cos theta. Therefore, the only force there will be what? For the one that is vertical, it will be what? Minus mg. Please take note, minus mg cos theta. I hope you know the reason why it's negative. The reason why it's minus mg because moving downwards is a downward force. Therefore, for this now, the sum of the force here is 0, and here is t minus mg cos theta. Now, taking it over, it becomes t equal mg cos theta. mg cos theta. Okay, this is what we have here. I have what? mg cos theta. mg cos theta. This one is another force we can obtain at this position here. We that the tension force is the one that we balance or the one that will support this mg. Okay, it's the one that will support that mg. Therefore, this force is balanced. This force is balanced. This one is also balanced because it's supported by mg. This one is balanced and it's also supported by mg cos theta. Okay, this one is what we call the balance, meaning this one is balanced, this one is balanced. Okay, now I can now move on now. Let me call this one formula 1. Let me call this one formula 2. Formula 2. Now, let's now look at the other one, which is sigma fx, and the one that is sigma fx there, the one that is horizontal there is this, and which is minus mg sin theta. That is what we have, the minus mg sin theta. And this one, you know, as this body, as you display this body, you release it. Therefore, there will be an acceleration. Here, there will be an acceleration. Okay, it means that the acceleration here, this one cannot be 0. You know, here was 0 because the sum of forces was 0 at that position. But for this one is going to be, see, the direction is negative. As you release it, to move to the left. Therefore, this one becomes minus m a, okay, equal minus mg sin theta. This one will be, okay, now we can now say now that minus m can kill minus m. Mean that what will be left there, at that position what we left, we are going to be having, okay, we are going to be having, at that position there, we are going to be having this very one. Okay, now what we have there, meaning if m minus m k minus m, we are going to be having our a, what we left there will be a equal g sin theta. We are going to be having m, okay, we are going to be having g. We are going to be having g minus m k minus m. We have a equal what? G, which is the sin theta. G sin theta. That is what we have there. That is what we have there. Please take note of that. It is very, very important. It means that for this one now, there is no force here, meaning this one is not balanced. But for this case, it's balanced because there is a force that is needed to support this, which is the tension force. For this one, it is balanced. But for this one, it is not balanced. This one becomes unbalanced force. This one becomes unbalanced force. I can call this one formula 3. Formula 3. I can call that one formula 3. Please take note of that. Take note of that. Take note of that. Okay, now for any small displacement, it forms angle theta, and sin theta is approximately theta. Sin theta is approximately theta is equal s over L. S over L. Please take note for any small displacement. Remember, I displayed this very one just now, this pendulum, and it forms a small angle. Now, for any displacement, it forms an angle theta. It forms angle theta, which is this very one, and sine theta is approximately theta, and it's equal S over L. Now, for here now, I can now put this very one here. Now, here become A equal G, it means that in place of sin theta, what will I put there? I'll put theta, and that theta, don't forget, I said is look at it here, it's going to be S over L. S over L. Okay, now from what we have here, I can say A is equal G over L X. Okay, can say X here, X. Okay, now the only thing constant there is that here now is constant, I mean this very one is constant. Remember from what we have here, I told you that the length is constant, and the only okay, if the length is constant, it means that we also have another thing that is constant there, which is G as a relation to gravity. It means that the only thing constant here is G and L that is constant in this pendulum. G and L are constant here. It means therefore now this will be our new acceleration. We take note of this. Let me call this one formula 4. Formula 4. Now from here now, please don't forget from simple harmonic motion, that is from SHN, which is simple harmonic motion. Remember that our acceleration is equal minus angular velocity, is equal to angular velocity uh, and the product of the displacement, which is the S. Remember, we have A to B equal minus the square of angular velocity times the displacement, which is the X. Like this very one here, this very one here. Now, to do this, okay, let me do it here. It means that this one here is from SHN, please take notes. This one is SHN, simple harmonic motion. And also forget from circular motion. Please don't forget from circular motion. Circular motion. Remember, we have done circular motion before. Do you know that if a body decides to move along this path of this circle, what happens? And if we decide to move it to this position, it will form an angle. It will form an angle, and that angle will be theta to form an angle. It means that we also have an angular velocity here. It means that the angular velocity here is going to be the angle turned through, is going to be the angle turned through, that is angular velocity, the angle turned through all over the Li's time, all over the Li's time. It means that this position, if I cross multiply now, I can also represent it as small t or big T, anyone. Okay, if I cross multiply now, therefore I'll be having my angular velocity to be, okay, we are going to be having, okay, I'll be having my theta. I'll be having my theta. Here, theta will be angular velocity t. It means that this position here, we have theta to be angular velocity at that position there. Please take note of this, take notes. And remember that this theta is in degree, and therefore we need to convert it to radian, become what? 2 pi, become what? 2 pi all over small t, okay, which is the period there. Okay, from what we have here, I cannot see that from what we have there, I cannot see. Okay, now we already know this one. Now we already know this. We take note of this very one. Okay, take note of this very one. Now, from the simple pendulum, because these are our major concern. From this one is a simple pendulum. This is what we are dealing with. Now, you know that the acceleration here is going to be directly proportional. You know that the acceleration will be directly proportional to the displacement. Do you know as you release this pendulum, it will come to the original position. You know the acceleration will be directed towards the left, and it will move along this path, and the distance there is x, and therefore the direction will be negative. Okay, therefore in this case, I cannot see a. I will introduce a constant here, become k, and okay, let me just say minus ks, which is the displacement. Okay, remember I told you that this one is the constant. Remember I told you that the only thing constant here is the L. You know the length does not change as you have a small displacement. The L, which is the length of the string, doesn't change. Now in this case, I can now say that my A here becomes become uh, putting this one, because this one is the one constant here, become minus G over L, which is S. Okay? I think you are very much correct. And from what we have, remember I told you that our omega, which is the angular velocity, is equal to pi, which is 2 pi over t. 2 pi over t. Okay, now from what we have here, I think we can still proceed. We can proceed and see, okay, I can replace this very one. Okay, I can replace this very one here. I can replace this very one here. Please take note, this very one, I can put it here. If I put it there, it becomes, okay, in this place of acceleration, here, I can see that minus g over L x, which is this very one, okay, it will be equal minus angular, equal of the angular velocity x. It means that this one here can keep this one. Negative can also eliminate negative. Therefore, we have g over L equal omega, which is the square of the angular velocity. That is what we are going to be having. The meaning from what we have here now, we can now move forward. We can now push forward and determine the time period of oscillation. Now we are set to go now. We are set to go. Okay, let us now clean one part of the board so that we can now resolve the time period of oscillation and determine the formula for it. Okay, now for the time period of oscillation, I think we can determine it from here. From here, we are going to determine that. Remember, I told you that our angular velocity, which is 2 pi over t, we can now use to replace this. Okay, before we do that, let us take the square root of the both sides. Let us take the square root of the both sides here. If I take the square root of the both sides, I'm going to be having the angular velocity, which is the square root of g over L. This is what I'm going to be having. It means that we are having g power half, okay, power half, and also L power half. That is what we mean there. It means that the square root belongs to g and also affect g, also affect L. Therefore, this is what we are going to be having there. It means that in this case now, I cannot replace my angular velocity. The angular velocity here is simply 2 pi, is simply 2 pi over t, which is the elapsed time there, which is the elapsed time. Remember, I told you, I said the angular velocity, the angle turn through conceptual motion, the angle turn through all over elapsed time. Now, from what I have here, I cannot use this one, become g power half all over L power half. Power half. Okay, now we can proceed and see. Now I can decide to interchange the position. I can say t, I will interchange it, because t over 2 pi. Now this one will also change, become L, okay, all over g, with the half g, will be g power half and L power half. We can see what happened there now. Now in this case now, what can we do? I will change t to the capital letter T with the period. This one will become what? 2 pi. Now what would I do? I'll multiply both sides. Okay? Okay, let me just go straight there. Multiply both sides by 2 pi. If I multiply both sides by 2 pi, I will have t. That 2 pi will leave here. Here become what? 2 pi. And now, remember this one is half, which is the power. I can decide to take it again to the root of L over G. Okay, I cannot say now, therefore I can conclude that my time period of oscillation, is equal to what? T, which is equal 2 pi L over G. This one will become the time period of oscillation. This one will become the time period of oscillation. Please take note of this very formula. We are going to use it to solve in our subsequent teaching. We are going to use it to solve in our subsequent teaching. Okay, I think we can just okay, we can also determine the other one. Remember, I gave you two things. I said we'll also determine the one of the frequency of oscillation. You know that frequency of oscillation is simply the inverse of is simply the inverse, or the frequency is simply the inverse of the period, the inverse of the period. Therefore, for the frequency, I can say, or we can say that we call the inverse. The inverse means that this one here, we have to change, that G become up, while the L will not come down. Okay, you have to take the inverse here. We got 2 pi over 1 is the same thing as 1. Then when you take the inverse, it becomes 1 over 2 pi. That is the reason for this 1 over 2 pi. Also take the inverse of this one, the G will come up, the L will come down. Meaning the inverse. It means that for the frequency is the inverse of the period. The inverse of the period. You take note of that. Very, very much important. Okay, at this point, I'm going to stop here. I'm going to stop here. It means that for the time period of oscillation, this is the formula we use, which is 2 pi, the square root of L over G, while for the frequency of oscillation is 1 over 2 pi, square root of G over L. Okay, thank you for joining me at this point. Thank you for joining me. Please don't forget, my page still remains, JB Jumbo Online Mathematics. You can join me at JB Jumbo, or you can join me on that platform, JB Jumbo Online Mathematics. You can also join me for the one of the YouTube Mathematics Science Mega Tutorial. On those two platforms, you can ever join me, and you have a lot to get, you have a lot to gain at the end. You know, no knowledge is waste, is lost. Every knowledge is important. It is very significant. Please endeavor you join me at these two platforms, and you will have a lot to get to have at the end of the day. Thank you once again. I am so glad, I'm so happy that you are part of today's teaching. Thank you. All the best. I wish you all the best. God bless you.